Okay, so we're now going to walk through doing a full hypothesis test using what's called the p-value approach. Now, the concept behind a p-value approach to doing this is the idea here is that we have some sort of level, okay, and it's going to be this thing called an alpha level. And basically what we're saying is this is the level that if we get below this amount, then we will reject. So think of this in terms of we could put somehow like an innocence meter on a particular individual. Now, we already have somebody that's been convicted of whatever the crime is. And their meter was at, when their meter of innocence got down to 10%, we convicted them. So now this new person is on trial for murder or for whatever the crime is. And I have their innocence meter. And as evidence presented and stuff like that, then their meter starts to come down. If their meter ends up below, say, this 10% marker that's already been set, then we have to convict them. We have to reject their innocence in order, because we've already convicted at that 10% marker or 5% marker or whatever we set the marker at. But if their level does not get below this predefined level, then we can't convict them. We're not willing to send them to prison or send them to jail on a chance that they could still be innocent because their meter level was higher, okay? So the way that this is going to go is we're going to start any hypothesis test, no matter what we're doing, by saying the null and the alternative hypothesis. So that's going to start out, okay? And this level, this significance level called alpha, that is going to be given to you. They're going to state, check at alpha equals, and these are going to be, some of the common ones are 0.10, 0.05, okay? They'll do stuff like this. Now, we are going to have to test our finite test statistics. So we've got this formula, Z equals P hat. Now, again, that's our sample statistic minus P naught. Now, that P naught is going to be the thing that comes out of the null hypothesis when we're talking, okay? Over, and then we've got this big square root of P naught, 1 minus P naught over N. So we'll have to do that math. And then we're going to calculate this p-value. Now, if it is a left-tailed test, then this test statistic, we're going to find the area to the left of that, okay? If it is a right-tailed test, then we will find the area to the right of whatever our test statistic is. If it is a two-tailed test, if it is down in the left end, then we'll find the area to the left. And if it is up in the right end, then we'll find the area to the right. But we have to double, because we talk about a two-tailed test, could be in either end. And then we'll make decisions as to whether to keep or reject or whatever we're going to do, okay? So we're going to take a look here and doing our lovely bit of math, okay? So the example that we're going to start with is we've got 444 smokers, and we have 187 reported that they had used a patch to try and quit smoking, okay? Can we conclude that less than half of smokers have used the patch? Okay, and then they're going to ask us to set this at alpha is 0.05. Okay, so first thing that we're going to do is we're going to set up our null and our alternative. Okay, so they're saying that it is, based on verbiage here, less than half. So since they're saying strictly less, that is automatically an alternative hypothesis. This is 0.50. So this is going to be 0.50 up here. Okay. So now the next thing is I need to find P hat. That is going to be 187 out of 444, which is going to be 0.4211711. And I'm running a lot of decimal places there. Okay, so we'll pull that up there so you can see. Okay, now I need to find my test statistics. So again, that formula was P hat minus P naught over square root P naught 1 minus P naught over N. Okay, so this is what this looked like. So we've got 0.4211711 minus 0.5 over square root 0.5 1 minus 0.5 over 444. Okay. So doing a little bit of math in between there, okay, we are going to get 0.42117 minus the 0.5. All this loveliness down here on the bottom is 0.0237276. And when we do all that lovely, we get negative 3.32. Okay. So now then, going to one of our lovely little bell curve charts. Okay, so utilizing one of our bell curve charts. Okay, we are going to go look. Okay, remember on our bell curve chart, we're going to use negative, and I'll close this up here in just a second. Negative 3.3. So here we go. Negative 3.3, and then we're coming all the way over here to 2. So we are at 0.005. Okay, and because this was a less than, we know that this is a left-tailed. So this is going to be straight from chart. So my p-value is that 0.0005. Okay, so now going back to that concept that I was talking about before. Here's where we already convicted somebody. We convicted somebody at 0.05. This is the current person that's on trial. Their innocence level is at 0.0005. Okay? Since this is less than this, so my p-value is less than alpha, then we are going to reject H naught. This is our conclusion, to reject H naught. Okay, so that's how that's going to look. Okay, so let's talk about doing another one here. Okay, so we've got vertical banded gastroplasty. It's a surgical procedure that reduces the volume of the stomach in order to produce weight loss. We've got 82 patients with type 2 diabetes underwent the procedure, and 59 of them experienced recovery. Does the study provide convincing evidence that more than 58% of those with diabetes who undergo the surgery will recover? So we've got H naught, H1. They said more than, so that's greater than 58%. Okay, so this will just be equal to 0.58. And this is now going to be right-tailed. Okay, so this will be a right-tailed test. Now, for p-hat, we've got 59 out of 82. So 59 out of 82 is 0.7195. Okay, so now setting up our test statistic, it's p-hat, so 0.7195 minus p-naught, which is 0.58, over big square root p-naught, which is our 0.58, 1 minus 0.58 over 82. We're going to get 0.0545041. This is going to get me 2.56. Okay. Okay. Now, with this being right-tailed, okay, we need to find the area to the right. So again, if we're looking at a pretty picture, here's our 2.56. I need to find the area to the right. So going to my chart, here's my chart again. And I'll again zoom down for you guys. We are going for 2.56. So I'll bring this down. So we've got 2.5. And then we're coming over to 6. So I've got 0.9948. So I'm going to do 1 minus 0.9948 is 0.0052. Now, if we were checking this, okay, and so they specified alpha is 0.10. So again, my p-value is 0.0052. Here's my alpha. My p-value is less than alpha. So again, this is where I already convicted at. This is my current person on trial. They are less innocent than the person that I already convicted. So we're going to reject H naught. So that means that I do have enough evidence to say that more than 58% did this. Okay, so there's a left-tailed and a right-tailed so far. So now let's look at a two-tailed so that you understand what this is going to look like. So we've got an article reported that 73% of companies have a Twitter account. An economist thinks that this percentage is different at technology companies. She samples 70 companies, so 70 companies. These are technology companies, and finds that 44 have Twitter. Okay, can she conclude that the percentage of technology companies that have Twitter differs? Okay, they said the word differs from 73%. Okay, when it says differs, they're not specifying whether I'm higher or lower, just that it is something different. And we're going to use alpha is 0.10. So, setting up hypotheses. This is going to be not equal to 0.73 and equal to 0.73. Okay, so this is going to be two-tailed. Okay, so now let's find p hat. 44 out of 70 is going to be 0.6285714. Okay, so now finding our test statistic, I've got 0.6285714 minus 0.73 over big square root 0.73, 1 minus 0.73 over 70. This is going to give me negative 1.91. Now, because this is two-tailed, taking a look at a picture, my mark line is here. So this is where negative 191 is. So I'm going to find the area to the left, but I have to mirror match that to do this up here. This total will be my p-value. Okay, so if I go look on my chart at negative 1.9, and I'm going to go ahead and find this for us, 1, I get 0.0281. So this side is 0.0281. Okay, so now I need to double this. So 2 times 0.0281 is 0.0562. Okay, this is my p-value. Now, at alpha 0.10, which is what they told us originally, again, they are less innocent than here, so we would reject H naught. Now, point of contention here, point of note, if we had said alpha is 0.05, okay, if this had been the alpha that they would have had us check on, is at 0.05, this person is above and has more innocence than this. So if this was the case, we would fail to reject. Okay, because I know we've had a couple of rejects in the last couple of examples. So I want you to know that it's not always going to be a failed or a reject. So I want you to see that this is, it is truly a comparison. So since this is higher than this, in this case, the p-value is higher than alpha, then we fail to reject on that particular situation.